in order to proceed with the project, I gotta do some alteration to the forging tool. So this is the forging tool prepared for the next step of its life. As you can see, it's a sign fixture, and I already marked the business end of it. If I turn it your way, you can see that it's been through some damage. There's some scoring and marking on the surface, but essentially what I'm trying to do is to minimize the wobble of this roller inside the pocket. So you can see it's got quite a wobble, and it's due to the fact that it's a development process, and I'm trying to see how good I can make it. I think it would work with that much wobble, but I'm trying to tighten the tolerances a little bit. So here's the initial drawing for the forging tool, and this is the portion of the tool that I dreamt up. You can see it's got 88 degrees, so it's a 2-degree taper per this side, per that side. And then I got certain dimensions here, so at 16 millimeters, the thickness is 806 millimeters. And then it's 694 at the tip. Now, this dimension here, the 694, is really hard to measure, since what I did is I dressed a smaller radius here on the tool. So that's why I'm giving the 16 millimeters, so 16 millimeters from this surface to here, and I'm measuring across. So that's just a control dimension. Now I looked again at the construction. So here's revision 2 of the print, and what I did is I changed the angle to 89 degrees, so that would result in 1 degree taper, and the size will be 7.4, so we went from 806 to 7.4, so that's 0.66 millimeters less, and accordingly the size of the tip changed about a tenth, and that is due to the way the taper is. So here's the old taper and the new taper overlaid. So you can see this is the new taper, the inner line that has 89 degrees, and then the outer line is 88 degrees. Well, the point is that I need to come in with a tool and basically alter the surface so that it would represent that 89 degree line, and it would be a little narrower here. Being narrower at the tip, which will forge the bottom of the cavity, it will decrease the wobble at the bottom, and at the same time, at the thick end of the tool, which will create this top edge, or the top surfaces, I can tighten the tolerances. So as you can see, it's 0.36 per side, so about 0.7 millimeters total. So this gap here, if I do everything correctly, will become 0.7 millimeters less. So let's do this. We're gonna go take that as an absolute measurement, and then we're gonna measure this size here carefully. So it's 1.47. So that 1.47 will be half of that, basically. Everything on YouTube happens fast, and I think it gives the false misconception to people that, even best machinists will just throw everything together and it will just happen. Well, it's not the same in the shrine. In the shrine, things are going in their own pace. For example, setting this up as you see it, took probably 2 hours, just finding the parts, making sure that this surface here or this surface is parallel to that surface so that the V-block is not crooked. So this is a 5-inch V-block, So from this pin to this pin, it's 5 inches. If I want to set the taper here to 1 degrees, I gotta install a certain amount of spacers here, which I calculated, and I installed the spacers. Now the problem is that it didn't have a locking mechanism, so I had to make a lock here at the bolts. So no, she's steady, and she's ready to go. The next challenge was getting the surface grinder to run. This is the first surface grinder I ever operated. So some of the problems was making sure that the lubrication system is working so that it pumps oil to the ways and to the upper section, so everything is properly lubricated. Here's the pump. You pull this lever and it will slowly go back, and then this oil will be pumped into the system. The other problem was figuring it out if it's wired for 440 or 220, getting 3-phase to it, and so on. Well, the next challenge was to clean all the parts here which were rusty, set up a grinding wheel that will be good for grinding steel, and then balancing it. At the end of the day, I was able to do a couple test grinds. So here is a 1, 2, 3 block that I just used for setup. Someone sometime created it. It's not really a precision something. So I just went ahead and ground this surface. As you can see, it's nice and shiny. It's got some ripples on it. Maybe I need to do a better job of dressing the wheel, but overall it's a real good result. Talking about a wheel dresser, I didn't have one, so I had to make one. I already had the diamond on a dressing stick. Don't be misled by ½ here. This is not ½ inch, this is 11.1 millimeters, which would be, I think, 7/16. So here's the block I created, and what I did is I ground this surface and this surface parallel on the grinder, so you can see this will accept that dressing tool, and the tool is set at 15 degrees plus minus something. But check this out. So this is my real first grind on the grinder, and I'm gonna put here, that's a 1 micrometer indicator. So this is a 1 micrometer indicator. Look at that. It's rock steady. So for the uninitiated, that means that the bottom surface is parallel to the top surface within 1 micrometer. And I did that in my workshop. You know, it's hard to comprehend, you know, how accurate that is. People don't have a grasp of 1 micrometer. You know, if I tell people that, yeah, your hair is about 50 microns thick, and this is 1/50th of that. So the needle is rock steady, it's not even moving. So most likely the tolerance is even tighter than that. But I'm really happy with this. So with all that being said, I'm ready to go and grind the tool. The first thing is just make sure that the table is free of contaminants. In every book, in every video you ever see people talk about this, they say just use your hands, and your hands are the best wipers to make sure it's clean. I also stoned that magnetic chuck, and then here is the tool. So the tool is gonna bump against this fence in the back, and then once I turn the magnetic chuck on, hopefully it will hold steady. So this is absolutely not recommended, but I'm gonna do a plunge cut basically with the grinding wheel. So first I'm gonna bump the end of the wheel to the tool here when the wheel is not running. Okay, I'm just gonna use a piece of paper, and then I'm gonna advance the wheel inward 16 millimeters. And basically at 16 millimeters, I'm gonna know I need to go down 0.33 millimeters. So that is gonna bring me to size, and then I'm gonna advance the tool out and then grind the rest of the part. I installed an indicator here, and the indicator is touching the top surface of the tool. So I just want to move the table left and right and make sure that the part is positioned flat relative to the magnetic chuck. And you can see the needle moves a little bit because there are some surface irregularities, but overall it's the same size. So now I know that the tool, the surface of the tool is horizontal relative to the magnetic chuck. The next thing I'm gonna do is, when the wheel is stationary, I'm just gonna bump the tool into the wheel, and I'm using a piece of paper to figure out what that gap is. So right there. So now I know that the tool is touching, you know, the wheel. And remember, right now it's not being held by the magnetic chuck. So turning the wheel slowly, I can hear that it's touching the tool. So that will be my zero position in the axial fashion. So now I can raise the wheel just to give some clearance, and I can advance the table in for 16 millimeters. From the hum, you can tell that the phase converter is running. The next thing is to turn on the magnetic chuck, which is on. Crank up the power to full, and I'm trying to lift this off, but it's not coming. It's in there good. And then turn on the motor. I got my indicator zeroed out. The size I need to grind is 330 microns, and I'm gonna do it in 25 micron increments. So I'm gonna take the tool out and then bring it down for 25 microns. And just keep making chips. That coasting down sound, that is so cool. There's a lot of energy in this wheel. If for whatever reason it would disintegrate, I don't think this cover would do much. Check this out. It's absolutely smooth finish. And hopefully I got it to size. Unfortunately, I cannot measure it until I turn it 180, and then I grind the other surface too. Check this out. I was indicating the top surface, which is still a machine surface that's been through hell a couple times when I was forging the parts. So it's got its patina, but the bottom surface is the ground surface that I just created. So what I'm gonna do is push down this needle like so, bring the tool over, and now I'm gonna sweep the tool on the ground surface, and look at that needle. That needle is just absolutely stable. So right now, with great confidence, I can tell you that this bottom surface is parallel to the table. So next thing is to grind the top. So that would be it. Both sides are ground. The part is absolutely cool. I didn't remove much material. There's a new tool in its entire beauty. These surfaces are just silky smooth. There's this step. I'm gonna go and sleep on it. What I'm gonna do about this step, but I really don't care past the 16mm mark. I just want to remove this step so that there is no sharp corner transition where the part can crack or fail. So this size at 18mm should be 747. So let's see what the micrometer shows. Obviously it's a tapered surface, and I'm measuring with the edges of the micrometer, but as you can see it's 749. So it's basically 25 microns off. 25 microns, that's 1 thou. And then as you can see it's consistent, it's 7495 on the other side. So now I have the 1 degree taper on both sides, and I got the same size on both sides. So I'd say that's good. Here's my optical comparator. The tool is in the optical comparator, and you can see at 10 times scale, shadow of the tool is projected onto it. I printed a 10 times scale drawing, so if I overlay it, you can see we are looking at the inside lines. If the universe would help me. So we are looking at the inside lines here. You can see good agreement for the angle and right there. So both the thickness and the angle has a good agreement. Now the end of the tool is blurry because the optical comparator can be focused to a certain plane here. So I can go and bring the end into focus, but because this is a curved surface, I am really fighting the universe. So you can see either I bring this section into focus, you know, this area, or I bring the end. So it's a good agreement. Another thing I wanted to show are these shoulders here. So you can see that this shoulder is touching the center line, and then this shoulder is off. So I didn't do a good job of bringing the wheel out and basically grinding them to the same level. The next thing we're gonna do is try to add the big enough radius here, kind of relief, and so get rid of this sharp corner, because that ground corner considered to be a sharp corner. If the tool will develop a crack or break, most likely this is where it's going to happen, either here or here. So I'm going to go and devise a way to grind a radius here. Like so many times before, the good old Bridgeport comes to the rescue. I got a Rockwell grinder installed, and the first thing we're gonna do is we're gonna dress the wheel. So here's the wheel, there's the dresser, which will make sure that it will run through. I'm not gonna run the orbital motion of the Bridgeport. I'm just gonna use the high-speed grinder to come in and adjust that radius. So now the wheel is dressed, it's time to put in the part and start working on the radiuses. Carefully, 101, I put an indicator against the face. The tool is sitting horizontal, I hope. Yeah, it sits horizontal in the vise, in the V block, and I'm sweeping this indicator up and down. So you can have a look-see. So let's zero out the Y like so. And I'm going to go and sweep up. And I'm going to go and sweep down. So one division is 10 micron. So it's within 10 microns, I would say. The first thing I'm going to do is just come in on the X. Kind of position it in the center. And I'm going to come in until the wheel touches the end of the part. And I'm slowly turning the wheel so I can feel when it bumps into it. Remember, this is already dressed. Okay, so now the wheel is touching the tool. So I'm going to go and zero the X. And now I can advance the X in to this line where I'm going to do the grinding operation. Now I move the wheel in for half a tool radius so that the center line is aligned with the edge here. Now I can move it in for the desired size, which is 18 millimeters in this case. So there you go, 18 millimeters. Now I'm going to lock the X. So it's not moving in the X direction. And all I'm going to do is just operate the Y. Well, this is going to be really loud, so now you're not going to hear much from my voice anyways. So the next thing is to grind that radius. What I'm going to do is essentially turn on the grinder and then exercise it up and down like so, and then feed in the Y until I get the desired radius. So we're gonna use it like a jig grinder, I guess. So the first side is done. Yeah, I'm just doing a visual inspection, and sharp corner, it looks like the sharp corner is gone. So we go to the other side. Part is cold to touch, it's not even warm. Here's the part in the optical comparator, and you can see the two radiuses that I ground. So here's the bottom one, here's the top one. The part is really not symmetrical because I screwed up the position of these shoulders that were there, the sharp corners. But despite that, I came in and I basically narrowed this cross section. The part right now will be stronger, both in a cyclic load, so when this thing hammers many times, or in a monotonic load when you just do, you know, one or two hits with it. Because this large radius here is a ground, nice polished surface, it will be a lot stronger. So what I've been doing when it was on the machine, I was trying to sense with a razor blade if there's a detectable edge here. I was doing a mechanical edge detection and I couldn't find anything. So one side took 330 microns, and then the other side took only 200 something microns, but there's no sharp edge. Hello, Andon Star microscope. Let's do a zoom on the screen. I'm sorry, I don't have this figured out yet, how I can record the video from the microscope, but I promise you I'm working on it. So after some adjustment, that is the picture we can see. So this is essentially the ground surface. You can see where the forging tool business end terminates, and then there is the ground surface. That's what it looks like. You can see there is no sharp corner in this area. You can also see the difference between the surface ground, the jig ground, and then the machine surfaces. So you can see that the machining marks look like mountains relative to these nice and smooth surfaces. So that's what it looks like. Here's the other side. You can see that the jig ground surface doesn't go that deep, it's a lot shallower. So with that, thank you for watching. Hope you guys got a kick out of this. I gotta add dress a radius here. I'm gonna save you from seeing that, but otherwise this tool is ready to strike, and when it will strike again, I promise I'll get you guys back so you can see the progress. Until then, take care, and I see you next time. And if you're not subscribed, please do so, or leave a comment. Bye. Got a little boo-boo here. The collet of the jig grinder ran in this corner, caused a little damage, but I think I can buff that out. Thing of a beauty.